The trick I'm going to teach you today is how to identify the catalyst and the reaction intermediate from the reaction mechanism. Here are some facts I want you to memorize. M stands for memorizing. Number 1. A reaction mechanism shows a series of sequential steps of a chemical reaction. Each step is called an elementary reaction or a molecular event. Number 2. A reactant of the overall reaction appears as a reactant of one or more elementary reactions only. A reactant of the overall reaction never appears as a product of any elementary reaction. Number 3. A product of the overall reaction appears as a product of one or more elementary reactions only. A product of the overall reaction never appears as a reactant of any elementary reaction. Number 4. A reaction intermediate, often abbreviated as an intermediate, appears as a product of an elementary reaction first, then appears as a reactant of the following elementary reactions. Number 5. A catalyst appears as a reactant of an elementary reaction first, then appears as the product of the following elementary reactions. As we can see here, both a reaction intermediate and a catalyst can appear on both sides of an elementary reaction. The difference, and the only difference between the two, is the order they appear in the elementary reaction. A reaction intermediate always appears as a product of an elementary reaction first. A catalyst is exactly the opposite. A catalyst always appears as the reactant of an elementary reaction first. Let me use an example to explain how to identify the intermediates and catalysts. This is the overall reaction, and it occurs in 2 steps. This is called the reaction mechanism. Step 1 can also be called elementary step 1 or elementary reaction 1. Similarly, we can call step 2 elementary reaction 2. Let's start from the first chemical, nitrogen dioxide. When we look at nitrogen dioxide, it appears as the reactant of elementary reaction 1. Then it appears as a product of elementary reaction 2. From the definition, nitrogen dioxide must be a catalyst. Let's look at the second chemical, sulfur dioxide. As we can see here, sulfur dioxide only appears once, and it appears as the reactant. So, sulfur dioxide must be a reactant. The overall reaction confirms sulfur dioxide is a reactant of the overall reaction. Let's look at the third chemical, nitrogen monoxide. It first appears as the product of elementary reaction 1. Then it appears as the reactant of elementary reaction 2. From the definition, nitrogen monoxide must be an intermediate. Let's look at the fourth chemical, sulfur trioxide. As we can see here, sulfur trioxide only appears once. It appears as the product of elementary reaction 1 or step 1. Therefore, sulfur trioxide must be a product. And the overall reaction confirms what we claim is correct. Sulfur trioxide is a product of the overall reaction. Oxygen gas is the fifth chemical we have in this reaction mechanism. Oxygen gas only appears as a reactant of elementary reaction 2. From the definition, oxygen gas must be a reactant.